Welcome to Frankly Developing. I'm Frank, and today we're looking at domain modeling and the danger of using primitive types. Everyone starts learning about primitive types like integer, double, or strings early on. And if we want our programs to do something useful, we kind of have to use these. A good domain model, however, goes beyond primitive types. It supports you with proper validation, readability, intent, and a clear focus. If you want more insightful content like this, make sure to hit that like button below. Don't forget to subscribe and turn on notifications. By subscribing, you'll stay updated with our latest videos on mastering clean code practices and leveling up your development skills. Like, subscribe, and most importantly, let's keep building remarkable software. Let's take a look at an example. We have a person class here. As you can see, the primitive type of string is used in several places. For the name, the email, the address. How does this work? If you give any string, it's probably particularly not a good email address. So somehow we need to validate these things to make sure we have a proper address eventually. And if you work with these, you only have a string. It would be nice to have a real object with a class and methods to validate and check things. Well, that's not possible with a normal string, so let's see how we can improve on this situation. Get rid of this string that doesn't help us really very much at all. And let's introduce like an email class. As you can see, you can use that to construct the email object with that string initially, which is perfectly fine to use the primitive type for this. It might be a user input or something. And then you can do all sorts of validations. You can pick the email apart. So if you want to do this, let's start with some tests. And potentially we want to run through a lot of different email addresses. So maybe a query might be better. We try different, say, valid addresses. Should go sample that one. For this test, we can basically just construct the object, and we assume that nothing bad happens. We might decide that an invalid address just throws as an argument exception. So, creation process would be something like a new email object with this string. I could say it should not throw any of these argument exceptions. And that will be really fine for us here. So, in this case, let's build it. We have a test that we can easily extend. Also just create a new one. So do something like this. Run it. And of course, now it'll just work because the constructor takes any kind of string, right? Very helpful at the moment. So let's copy this over to a second set of tests where we test invalidates. So one example would be something like this. Maybe you know, maybe you don't know, but this is an invalid email address. You're not allowed to use 2 dots in a row unless it's a quoted email, which this is not. So we run this, or of course we should change our expectation. It should throw an exception. Now let's run it again. We should see this has an error at the moment. There's no validation yet, of course. And your email class can, of course, fix this and do checks like these double dots, for example. And we could throw the new argument exception. Provide probably better details than what we have here. I could rerun it, and in that case it goes green, it works again. So this is a way we could use an email instead here. And then we can construct our object, the person, right here. And now we don't have a string anymore. But this is just for validation. We said there's more to be had. For example, the email could also be deconstructed. I could retrieve the domain for an email. So when we construct an email like this, I could retrieve the domain of that email address. Say this should now be sample.com. We don't yet have a main property, so that's something we would have to introduce. Maybe we do it in a property here, deconstruct it in constructor. We're going very simple here by just splitting it and assuming this works out. Then clear that you can extend the validation to make this properly. And now we can introduce like a domain property on that, or we can directly use this as the property here if we want. I think that is quicker. And then we can basically deconstruct this email into its domain and local part and even sub-addresses, so you can make it as complicated as you want, basically, or rather as you need. See, the point is using this as a real object gives you immediate access to concepts in your domain. So it's not just that it's validated, it allows you to use it in a much better way so that it's more readable, and also it focuses your intention on this being an email. Just contrast this with the address, which is a string. Now here, if there's side by side, right next to each other, you immediately know that there's an email and an address. It's clear that the address is kind of like a postal address. But if you go to some other place in a big code base and use that part of it, and you suddenly talk about an address variable, it's no longer clear. Is it an email address or is it a postal address? If you have an actual email object or an actual address object, and this is clear. It's much, much clearer. We can also work with this. You don't have to think about, oh, where was this helper method again? Maybe it is somewhere else. So none of that really is any more important, because now you have this proper encapsulation where email is properly representing this thing in your domain. Now that helps you to avoid a lot of potential problems, as well as focuses all of your work with emails by using a proper representation, which is way, way better than just a string. It gives you nothing but normal string operations and has nothing to do really by itself with an email. Let's recap what we learned. Using proper domain modeling gives you a nice way to validate your object, have better readability, to have more focus. How far you take the server is a matter of experience and your program's needs. For example, the email class might still use a string for the domain part. Or domains might be really important to your program and deserve their own domain model. Whenever you see a primitive type, give it some consideration. It's your decision whether to upgrade it to a proper domain concept. Here's a quick list to demonstrate how much more clarity you can gain by that approach when you simply compare different integer usages. I hope you agree that the right-hand side gives a much clearer picture. I hope you found this valuable and will give some consideration to more effective domain modeling. You can look at this as a positive upgrade on primitive types, or you can call it primitive obsession if you prefer a negative term. If you encountered other examples of primitive types being misused, let me know in the comments below. Don't forget to subscribe for more tips like this. Thank you for watching and have fun developing.